Hello? We're good? Okay. Thank you all for coming. For the people that are used to seeing Paige up here, she's still around, but she's in Europe today. So if you miss her, you can wave at her through the live stream. Just say, hey, Paige. Speaking of organizers, we have a new organizer, and that's Thomas Hunt up there. Big round of applause for Thomas. We're super excited to have him join the team and look forward to working with you, Tom. So for the people, except for the Lightning Network, we also have Lightning Talks today. So if you want to do a short talk, just sign up at the sign-up sheet somewhere in the back. It says Lightning Talks. We have time for that after the speakers of today, which are Tadge and Joseph. Very happy to have you guys. They're going to talk about Bitcoin scalability problems. So without further ado, there they are.
Okay, hi. So yeah, I titled it Bitcoin Scalability Solutions because that sounds more positive than talking about the problems. But so I'll go through like the scalability stuff and talk a little bit about Lightning Network, and then Joseph will sort of go after that and like talk about what needs to change and things like that, right?
Yeah, and like the economics and things like that.
Okay, you can hear me? Cool. Okay, so I'll start. Okay, so Bitcoin scalability. The thing that's on everyone's mind right now is line 10 of consensus.h, which is static, constant, unsigned integer, max block size equals 1 million. And unfortunately, that's been in there for quite a number of years and hasn't budged. Yeah, so and in a larger, so that's like the current thing that people are focusing on. But the discussion quickly becomes a larger discussion of, okay, well, scalability-wise, if each node creates, transactions, and the transactions are stored by every node, that looks like a whole lot like n squared, right? And that's not considered very scalable. So I'll talk about, so this is sort of the problem. How do we get everyone to use Bitcoin? How do we get lots of transactions? And there's different solutions. So I'll talk about 4. Some of these are kind of a joke, not really. There's the SQL database model, which is very scalable, very, very fast, and you can implement off-chain transactions a day, ChangeTip, Coinbase, stuff like that. There's altcoins, and there's many blockchains and you can do interchain transfers. You could have larger blocks, and then the one we'll talk about at the end, payment channels, which is many payments between 2 predetermined parties. So I'll go through the pluses and minuses of these different models. The SQL database model is actually really fast. It's the most widely used off-chain model right now. 100 users send all their coins to one guy, and the one guy maintains an SQL database, key value store of user to balance, and then users can query and you say, okay, I want to transfer my funds. Nothing happens on the blockchain, and people just ask for the money back. It's very fast and can support millions of transactions per second. The problem with the SQL model is it looks a lot like the good delivery bars in the basement of the Fed in New York, which is a picture there. You don't actually have your Bitcoins. So there's counterparty risks, things like that. But it is very likely to happen if no other solutions come up. And it's already very popular, right? So people use these kinds of things right now. A lot of the time, ChangeTip, which, and it's not bad. Like, I think no matter what happens, there will be some of this in the future. And it's okay you don't want to be reliant on it though, right? Because then you're sort of kind of back where you started with, trusted entities handling money for other people. Altcoins. So you can sell your Bitcoin and buy some Nito coin, and you can transact fast with Nito coin, and it's HydroFlex negative block times, where block n+1 comes out before block n. It's non-causal. And then when you're done transacting with Nito coin, you can buy back your Bitcoin. So this is maybe a solution, but the problem is the altcoin exchange in general is just like the SQL model. Most altcoin exchanges that I've seen, you give all your coins to it and maintain balances in their system. Atomic cross-chain transactions, where the cross-chain is between different, completely different currencies, I've seen that it could work, but I've never seen any exchange using that. It's kind of a cool technology, but I don't know if any actual altcoins use it. And then the other question is, okay, if Needlecoin really works or not, a lot of altcoins don't and don't have the security that Bitcoin does. But if it does work and it is scalable and there's no problems, well, why aren't we just using Needlecoin? That if something really does present better scalability and security than Bitcoin, well, gee, maybe that's going to take over. It's not really a good solution for Bitcoin because it's not Bitcoin, right? That's sort of pushing the problem somewhere else. Okay, and then larger blocks. I'm going to gloss over this real fast because this is everyone just starts arguing. So computers are great, Moore's law works, and even if it's 100 megabytes a block, well, that's only 5 terabytes a year, and 5 terabyte hard drives are under a Bitcoin. So just increase the block size, right? And if you were actually filling 100 meg blocks every 10 minutes, presumably a 5 terabyte hard drive will be well under 1 Bitcoin, because that means you've got hundreds of times more transactions and more people using it than there are today. And CPU RAM-wise, have you guys tried version 0.10? I mean, it's pretty awesome. It's way faster, especially if I have a slow spinny hard drive for this. So I run a full node on a 2005 or 6 era laptop that I found in the garbage, and it runs fine. 0.10 is a lot faster. And in 0.11, there's going to be pruning, which is going to be ridiculous, right? There's go down to 1 gig or something. So there are a lot of reasons where you can say, hey, 1 megabyte's really small, and from a technical standpoint, you can do a lot more. Another reason is, if you look at the sort of computer science-y angle, n squared's not that bad. It's not like it's 2 to the n or anything. And if the total network cost is something along the lines of n squared, well, for each user, it's still just O of n. And if the value of the network is something like Metcalfe's law, well, that's also n squared, in which case the cost is roughly proportional to the value, so it sort of scales, right? This is all very hand-wavy. So there are problems with big blocks, and miners are already pretty centralized. If you switch to 20 megabytes a second, well, that only gets you 80 transactions a second or so. It's not, world domination. You need much larger blocks for everyone to use this. And then what about the Internet of Things, right? If your fridge wants to pay your drone to go pick up some eggs, for all these IoT bots to be paying each other, that's going to be a lot of transactions. So larger blocks can help with scalability, but I don't think they're the only solution, right? They're necessary but not sufficient to really address this. So what I'll talk about for a few minutes is payment channels. And this is transactions that can be delayed and aggregated before being put onto the blockchain. And so now you only need an actual confirmed transaction on the blockchain when you want to open and close a channel. It's kind of a free lunch in some ways. It's got a lot of nice properties in that it's opt-in, you can do a lot of transactions, the confirmations are instant, and we'll talk about how you can scale it to a lot of users. Okay, so this is sort of the tech part. I don't know how many people have heard of the regular payment channels and how those work. This was Bitcoin J started, Mike Hearn. I don't know exactly where these ideas started and got implemented, but this part is not new. The basic idea is Alice wants to pay Bob, but she doesn't know how much yet. And she says, okay, well, I'll pay Bob up to a maximum of 1 Bitcoin. So I'll open a 1 Bitcoin channel. And the way that she does it is, first, she gets a refund, which is signed by Bob. But it's not valid yet. It's using nlock time. It's valid tomorrow. And after she gets the refund, she can now fund the channel. And the channel is just a simple 2 of 2 multisig, where both Alice and Bob must sign to release the funds. So since Alice has Bob's signature, from here, Alice can just sign herself and retrieve the funds tomorrow. Okay, so worst case scenario, even if Bob disappears immediately after Alice funds it, Alice just has to wait a day. No big deal. Okay, then what she can do is she can sign a transaction that's valid right now, and where she gives Bob 0.1 Bitcoins and 0.9 back to herself, and then sends Bob that signature, and sends it to him, not over the Bitcoin network, but just emails it to him or through a chat window or some other network. And now Bob has that signature. Bob can also sign that transaction and broadcast to the blockchain, but Bob doesn't. Bob waits. But what's nice about this is Alice, by sending Bob this 80 byte or so signature, it might be 100 bytes, it's pretty small, that's essentially a payment. And so that's really fast. What Alice then does again is say, okay, since Bob hasn't broadcast, I will pay Bob even more. I'll give him 0.2 and myself 0.8, sign, send the signature to Bob. Bob now can basically forget about this old one because that's purely worse than this current one. So Bob just keeps on his hard drive the most beneficial to Bob and overwrites the old ones. And so Alice can do this up to, keep doing it, 0.3, 0.4, whatever increments she wants. She can increment by 1 Satoshi. And eventually, if the channel sort of wipes out and it's all going to Bob, then Bob will probably immediately broadcast that because there's no, what? A lot of what? Oh, I can slow down? Okay. So then then I will go into a little more complex stuff because I think I gloss over. Yeah. Okay. So there's some problems with this. It's unidirectional. Bob cannot push funds back to Alice. I don't have a slide for that, but the way you do it is instead of this being no lock time, you make this tomorrow at lunchtime instead of tomorrow night. So Bob can only broadcast this tomorrow after lunch, and this refund happens at night, so Bob can still get the money. Then if Bob wants to send money back to Alice, he creates a new transaction with an even earlier lock time and sends that to Alice. So Bob, if Bob's at 0.2 or 0.3, Bob now says, okay, actually, I'll make a new one where I'm only getting 0.1 and you're getting 0.9, and I'll send it to you with a lock time that's closer to the present than what I have. And Alice knows, okay, well, as long as I broadcast that before Bob broadcasts this one, I get more money. And so you can, by bringing the time closer to the present, switch the direction of the channel. So you don't want to do it too often because you'll run out of time. But if you're only doing it a few times during the length of the channel, you can switch direction. Other one-to-one things we need to do? That's about it. Yeah. Okay. So for one-to-one, it's not. Oh, the other thing that could happen is instead of just Alice funding the channel, both Alice and Bob could put 1 Bitcoin in the channel. Maybe they're not even sure who's paying whom yet, but they know that they're going to be doing business with each other. And maybe Bob pays Alice, maybe Alice pays Bob, maybe a little both happen, and so they both fund the channel. That's actually where it breaks because malleability. So when you have 2 signatures funding this transaction, it's easy for someone to re-sign. The way Bitcoin works, you can sign the same message twice and get a completely different signature because of the cryptography. And that unfortunately breaks this refund because refunds have to refer to a specific set of signatures that they're spending. So that's sort of an issue. Okay, so given but basically this works now, and I think there's like Streamium or something now that's using this kind of stuff. So this works today, and it's pretty cool. Scalability-wise, it helps a little if you're doing microtransactions with one party already known. But if you want to do a lot, you can do, let's say you have a 3-party optimistic iterative, is what I'm calling it. Let's say Alice has a channel to Bob, Bob has a channel to Carol, and Alice wants to pay Carol without opening a new channel, right? Without even touching the Bitcoin blockchain. So the obvious, easy way to do it is Alice says, okay, Bob, I'm going to give you 0.01 Bitcoins, give it to Carol. And then Bob says, okay, I'll give it to Carol. And then Alice checks with Carol and says, hey, did you get it? And Carol's like, yeah, I got it. And then Alice says, okay, I'll give Bob 0.02. Hey, Bob, give him. Okay, now Carol gets 0.02, 0.03, 0.03. Works great. You just keep giving Bob a little bit, and then Bob keeps giving Carol a little bit, and you can increment without trusting Bob too much. The worst Bob can do is keep the 0.01, right? And this is kind of a problem, right? Because Bob can simply keep it, or Bob can send it on, and Carol can just claim she never got it. There's no real way to prove these things. With only 2 parties, it's pretty obvious that Bob was the one who kept your money. But if it's something like, Bob, Carol, Dave, and there's like a bunch of different intermediaries, it might not be clear who is breaking this transaction. So in general, like this is not that great because you have a trusted third party. You've got this trusted guy in the middle. And a lot of Bitcoin people don't like that kind of thing. So what you can do, you can have a multiple party. I say trustless, kind of. Trust is tricky. It's a better model. Alice wants to pay Dave without opening a new channel. So very similar to before. But what she does, and this is sort of like this is the Lightning Network, but a simplification of it. It gets a little hairy with all the different transactions. Dave comes up with a random number R and hashes it using, SHA-256 or whatever, and gets H. So H is the hash of R. R is secret. And Dave gives Alice H. Alice then says, okay, Bob, I will pay you a Bitcoin if you know the pre-image of H, which Bob does not, right? If you know R, I'll give you this Bitcoin. Bob then forwards it to Carol and says, okay, Carol, I'll give you a Bitcoin if you know R. Carol doesn't know R. And you can do this in a script in Bitcoin today. You can say, okay, if you can sign and you know the pre-image to this, random number, you can spend. Otherwise, you can't spend it. Carol then forwards it to Dave and says, hey, Dave, I will give you this Bitcoin if you know R, the pre-image of H. And Dave came up with R, so he does know it. Dave needs to show R, reveal R, if he wants to accept the payment, though, right? If Dave takes this transaction and puts it onto the blockchain, now everyone knows R, because he had to use R to spend it. Okay, so now everyone knows R, all the payments go through, right? Alice to Bob, Bob to Carol, Carol to Dave, they all become valid payments. What's nice about this is Dave can never take the money from Carol without these other two transactions being valid. And similarly, Alice never ends up paying Bob and Bob getting to keep the money, because if this transaction valid, they all become valid. So that's a nice model where Alice doesn't have to trust Bob or Carol, and you can have a bunch of intermediate nodes without worrying about one of them grabbing the money. Because as long as this system works, and it does, the only issues are sort of timing issues and stuff like that. You can keep these channels open. You can push through payments to other users, and you don't have to touch the blockchain until you want to close the channel at the end. There's other sort of, it doesn't seem that scalable, right? Because you're going to have to keep coming up with all these different new transactions each time. You can actually then clear this out later. That's a bit more complicated. But as long as everyone, so if you don't have cooperative nodes in the middle, the system can break down. But the worst that happens is your transaction doesn't go through. You don't actually lose any money. And then you can clear it out, and it's quite scalable. I think, so lots of payments to anyone within the networks. You don't have to make new channels. As long as there's a path between two users, payments can be routed. So it's kind of like the internet in that sense. You don't have to worry about your connectivity. Okay, I think that's, okay. So now, you want this thing? Yeah. Okay.
Okay, so I'm going to be talking more now about the Lightning Network, on its sort of philosophy behind it, and the risks, and also its applications. So if you see everything is going to be run inside a network of payment channels, what gets broadcast onto the Bitcoin blockchain sort of becomes like an programmatically adjudicated court system, right? So if in, like 99 point whatever % of all the contracts you write, like think of all the EULAs you click through, right? You don't ever go to court. It's not really enforced by any sort of system, right? Everyone just agrees to cooperate. However, if you do disagree, you do have some sort of fallback. And the blockchains you can view as this fallback, where with Lightning, you're creating real Bitcoin transactions that can be interpreted by the blockchain, much like how in the court system you can build contracts that are readable by a human judge. The difference, of course, with the Lightning Network is everything is automatic and programmatic, and disagreement should, basically never happen. And that's pretty interesting because you're creating these transactions that are real Bitcoin transactions, but, it doesn't ever hit the blockchain except for disagreements. But how does this work, right? I think it's very important to view any development in Bitcoin as, a replay of the history of money. Bitcoin is functionally, this base currency, and using this, we're sort of, at about 2000 BCE, right? That's sort of where we're at right now. but I think it's sort of a waste of time to repeat history and learn. It's ideal to learn from its mistakes and learn from the way systems operate today. I think there's oftentimes a reason. And the way Lightning Network works is it uses time as a function of atomicity. And in the real financial markets today, we have systems like T+3, which is for equities, which is that when you, for example, sell a stock, it must be completed within 3 days. And this is a hard limit, and it goes through multiple people. Your clearing, your broker, ultimately, settlement and delivery. There's organizations like, the DTCC, which handles a huge portion of all equities. And, like things like correspondent banking, different people have different responsibilities at different sets of time. Overnight is a huge component in the financial markets. And the way Lightning works is you create time commitments between the different hops. And the benefit of this over traditional systems is that these time commitments are enforceable on the blockchain. And, it's very difficult to have any sort of disagreement because it's all programmatically interpreted, which is a huge benefit. Like with T+3, the enforcement is sort of just you do this or you get fined, right? Which is not so good. It's a lot cleaner that, everything is enforced. You can have lock times in Bitcoin, and that can have significant clarity in the processing of financial transactions. And that's sort of how Lightning makes things effectively trustless. However, there are some considerations that you need to look into. Isolated attacks onto something like Lightning pretty much doesn't work, because if you decide to violate the terms inside your channel, it can be interpreted on the blockchain, and the interpretation is you can broadcast a transaction which penalizes the other party and take all their money. So if Alice has a relationship with Bob, Bob is a jerk and tries to attest something onto the blockchain. Alice can basically say, well, I can prove Bob is being a jerk right now. So Alice takes all the money in the channel, and Bob can't really be a jerk. Systemic attacks are theoretically possible on the Lightning Network, but is very unlikely. But is still possible. It requires basically a supervillain with, maybe like 1 million Bitcoin or whatever it is, and simultaneously try to flood the network. And they pay very high miners fees, and they use they need cooperation from malicious miners to interpret child pays for parent. Well, may not be malicious, depends on your interpretation. In any case, it sort of requires a lot of money to attack and is very unlikely, but there are ways to mitigate this depending on how you construct it, right? You can mitigate it by sort of having this soft cap structure in Bitcoin. So let's presume, unlimited block sizes, right? Like blocks can be as big as you want, 20 megabytes, I don't care. Miners are probably not going to mine unlimited blocks. Blocks are functionally going to be full most of the time, simply because if you allow unlimited blocks, transaction fees goes to 0. Miners aren't too happy with that. They're probably going to say, well, let's just restrict the block size. So I think no matter what you set the cap to be in Bitcoin, if it's too high, miners are probably going to restrict it anyway. Ideally, you want some kind of flexibility to dynamically increase the block size. If you do that, then the supervillain attack basically becomes borderline impossible, and it'll be disastrous for the supervillain. They're going to lose all their money. The benefit of blocks being mostly full is you create this nice fee market, and miners can be compensated eventually over, in the long term. And I think realistically, the chances of that happening are fairly low if there is some sort of soft cap structure. And I'm not saying, like 20 megabyte blocks tomorrow. I'm saying eventually you may need to increase the block size. And, for all it could be done in some type of, sidechain type structure or whatever. In any case, the economic implications for something like Lightning, I think, has some interesting effects. There's a lot of coins that'll be locked up inside these channels. Now, they're not really gone, right? It's just sort of your balance, right? Like if I have, if I have like 0.1 Bitcoin and someone else has like 0.1 Bitcoin, you would both put it in the channel. It's not like these coins are gone. They're just, associated between an individual for a set period of time. They are immediately available to spend, so you can route payments. You can spend that 0.1, I can spend that 0.1 Bitcoin and, send it to Carol or whatever it is. And the intermediary nodes have, funds associated with their, the people they have channel open with as well. However, the net effect of this is that, the funds available may reduce the money supply a little bit, and the effect of that may increase the price, depending on, whether you like that or not. I assume people in the audience do prefer that. It's not 100% correlation, but, there may be some side effect of that. I think, there will be some kind of fee market inside Lightning itself. The fee structure inside Lightning will be somewhat different than, the blockchain fee. The blockchain fee is for, opening and closing the channel and not, per payment inside Lightning. The fees, I think, can be positive or negative. There are situations where, let's say Alice has a relationship with Bob, Bob has a relationship with Carol, and Carol has a relationship with Dave. If Bob and Carol do a lot of traffic, there may be an incentive to, send the money the other way, right? So there may be a situation where, like Dave may want to send money. If Dave has a relationship with both Bob and Carol, then if a lot of money flowing in one direction from Bob to Carol, maybe Dave can offer some funds to go in the other direction. Yeah. This is totally different in terms of names, though. That's okay. I'll go over this again. We have time. So, like there's Aaron, right? Alice, Bob, Carol, and Dave. Let's say Alice is sending a lot of money to Dave. Dave is sending a lot of money to in Alice's direction. Aaron can move money between them so that channels are more available. And, Aaron is maybe just someone with a smartphone, right? And they can very easily, move money in the other direction. Aaron has the same amount of money after this. Let's say Aaron has 0.1 Bitcoin. She just moves it in the other direction, except Aaron sends some money to Dave and receives some money from Bob. And this is totally trustless, and there's no situation where like Aaron won't receive funds, All right, let me go back. Okay. So the economic incentives for the network, I think liquidity will exist for the network purely for this because of this fee market. If a lot of money is flowing in one direction, there's economic incentive to keep channels open. So I think routing will be a lot easier simply because, hey, let's say I have channels open with 5 different people. One person wants to move money in this direction, one person wants to move money in the opposite direction, so let's just net everything out. I just sort of don't care what my balance is between the multiple parties. However, channel liquidity may be a little bit more constrained, so there may be some type of fee that you pay if you're receiving a lot of money in the future. But I think ultimately the fees are going to be very, very low. But the way it'll be reflected in the long term is probably higher exchange rates to accommodate available channel liquidity. Basically, if you're receiving a lot of money, if you expect to receive a lot of money, someone needs to open a channel with you, and you don't have any money locked up, but the other person has a lot of money locked up. So because of that, they're locking up their own funds with no guarantee that all that money will actually be sent to you. So you're probably going to have to pay some small fee for that. But if you have Bitcoins laying around, you're basically making money off of it. So let's say if you have 0.1 Bitcoin, and you're not going to be spending it in the next couple months, right? Well, if someone's going to be receiving Bitcoin in the future, you can set up this channel with them, and they might pay you some small fee, so as basically some lease rate. But the interesting thing about that is you don't need to trust that person. That person can be a jerk for all you care. They can be trying to steal your money for all you care. This doesn't have any custodial risk, and you make some small fee just for like leaving Bitcoin out on this network. So I think there's a lot of interesting applications for something like this. I think, the holy grail, the promise of Bitcoin was micropayments. Right now, micropayments are functionally impossible. Everyone just uses ChangeTip, and ChangeTip is cool, but I think, for the long term, I think you need micropayments to scale out at least, for penny and sub-penny. It would be interesting to, let's say, pay per article for the newspaper. The newspaper industry is facing, huge problems, and I think it'd be interesting if, like, let's say, I read an article, I pay 2 cents, the ads get turned off, if you pay like, 2 cents, 5 cents, whatever it is per article, and it's low enough that you sort of don't really care. But in aggregate, it'll help. You can do like automated payments. Every website you visit, you pay a certain amount in some like header field. You could have something in your MP3 player where you just pay like a penny per play or something like that, where, maybe you get some benefit from the artist by doing this. Paying for micropayments for bandwidth is really interesting. Don't just think in terms of, your home internet connection. Cell phones, if, you have sufficient Wi-Fi everywhere and the APs allowed you to connect, if you paid some small amount, I think a lot of people would open up their APs, their access points, their wireless access points. Instant payments is really important. Paying for something right now on Bitcoin is sort of, there's some trust involved, accepting 0 confirmations. And you kind of want the confidence that if someone sends you an unconfirmed transaction, it'll go through. Right now, there's no guarantees. With Lightning, you can do instant payments, and that includes instant payments between exchanges. So you can do some, interesting arbitrage. But right now, ultimately, Lightning Network needs some changes in Bitcoin. The most important is a malleability fix in some form. That is pretty much critical, and Lightning Network can't exist without this fix. Full stop. It'd be nice to have some type of relative maturity system, also known as like op relative check lock time verify. It's a bit of a mouthful. And ideally, to protect against supervillains, you need to account for, something like 10x or whatever bursts in block sizes. And I don't think that'll actually occur. I think you just need the threat that this can compensate for it. If a supervillain sees that they will lose all their money if they try to attack the system, they're probably not going to bother. And also writing it, it's a bit hairy. There's like many different transactions. Building a network communication layer, especially that is decentralized, will take some time. But it is definitely possible, and I think long term, for Bitcoin to truly scale, you need to put things off chain. It sort of doesn't make sense that everyone knows that you bought a cup of coffee on the blockchain. All right. Questions?
Avish. Oh, so the problem with malleability is you can't, so all these things are off blockchain, right? None of these things are actually, so when you're spending in Bitcoin, you're referencing your input TXID, which is the hash of your input transaction. So even, I can go back to the part where it's just 2 of 2. Even two one-to-one breaks. Here, yeah. This actually breaks if Alice and Bob are both funding that channel. Because basically your refund has to be created before you fund the channel. Because otherwise, you can both put a coin in. You've got this channel with 2 coins in it, and there's no refund. So now it's a hostage situation. Now you've got 2 coins. You both have to sign to take those coins out. And Bob now says, all right, well, how much is it worth to you? I'll give you 0.9 back, and I get 1.1. And Alice is like, no, screw that. It's one of them's mine. And Bob's like, well, not anymore. And so the real attack is what essentially Bob does is the time value of money kind of attack, where Bob says, okay, I will sign 100 transactions, and I just give them all to Alice. And I say, okay, if you want the one that's current, they're all time locked. So the one that's time locked for today, Alice gets back 0.1. If Alice waits next week, she gets back 0.2. If Alice waits a month, she gets back 0.3. And a year or 2 later, she gets back 1. So if you want to wait, you can get all your money back. But if you want it now, I get to steal some. So that's sort of the attack. And the problem that makes it really hard to mitigate is the way ECDSA works, you can't actually fix the malleability problem by constraining the script. Because basically when you're doing ECDSA, you come up with a random number, call it K, and that's leads to the R part of your signature, and that's always different. And so Bob can sign the exact same transaction twice and come up with a completely different signature. And that will change the TXID of this red, channel transaction. And if the channel transaction changes its TXID, the refund is no longer pointing to the right place, right? The refund's pointing to TXID 5073, but it didn't end up being 5073 because Bob re-signed, and now the TXID is 20405. And so Alice has a refund, but it's not pointing to the right place. It's useless. The coins are stuck. So that's basically the issue, and it gets even more problematic with all these kinds of things. In that all these chain transactions, none of them are on the blockchain, right? So I'm spending this, which gets spent to here, which gets spent to here. So they're all based on TXIDs, which can be changed by any of the middle participants, breaking the whole chain. So the easiest way, I think, is you have a new SIG hash type which doesn't reference TXIDs at all. It just references your input script. And maybe your amount, because I know Greg Maxwell's like, well, it's dangerous if you don't. Anyway, so there's different ways to fix it. I mean, I think the main question is, do you have some kind of normalized SIG hash versus no TXID at all? And what the different benefits of those two things are. But basically, most contracts break, especially this stuff, if you don't have a way to reliably spend transactions that are not yet on the blockchain.
And functionally, if you want to make this channel bidirectional, you sort of need to be able to build the terms of this payment before it is funded onto the blockchain. So it's sort of the situation we have right now in Bitcoin is you sort of pay the other party, or you sort of pay. It's like if you want to pay someone else and build a contract, you need to pay them first before you write the contract. Why would you ever do that, right? It's like, okay, let's build a loan, right? Okay, you got to pay me back in installments. I'll pay you first, and we'll write the contract later. We'll figure it out. That's sort of the situation in Bitcoin right now, and the malleability fixes that problem fundamentally.
What's the realistic timeline to fix that issue?
The question is timeline. I don't know.
I don't know. It sort of seems not that tricky when you first think of it, but then there's all these like, well, wait, what if this is a problem? What if this is a problem? So yeah, the problem is then it sort of gets in where like people are like, well, if we're going to have a new SIG hash type, let's also make a new signature scheme, like with Schnorr signatures, and I want Schnorr signatures too, because you have these nice threshold signatures where you can do like 100 of 100. But then, okay, well, since we're doing these different signature types, let's all put it into one big update, and then so yeah, as if you've been reading like Reddit or any of these things, the politics involved in actually changing Bitcoin code is there's no like there's no algorithmic consensus for the humans writing the code yet. So it might take a while. Hopefully, end of the year, next year, I don't know, version 0.12, 0.13, something like that. But yeah, I don't know.
Is the discussion on the mailing list right now that Christian's
Yeah, it theoretically works.
I don't know which one. There's some normalized.
Some normalized don't
work.
Yeah.
Where if it's only because it'll only work for like one hop.
Yeah.
Is that the one he's talking about, or is it like
there's like a new one where
a
like
whole set
you basically
everything
persist
has
it? Yeah.
Yeah, that would work, but it's like a
Theoretically.
lot of extra data. You're basically doubling.
Yeah.
I
You're doubling the
personally, I
UTXO
think
set.
having a no TXID on SIGHASH is like the easiest.
Yeah,
And-
just don't use it if you're not building these
Yeah,
things.
and you can shoot yourself in the foot with it if you have, say, 2 spends to the same address in different amounts. Then you might try to spend the larger amount, or no, you'd spend the smaller amount, and then someone, probably the miner, would switch it to the larger amount and keep the fee, keep the difference as their fee. But just don't do that. If you're going to be using these exotic SIGHASH types, well, make sure you know what you're doing. I mean, there's already something called SIGHASH none, where basically you sign your input and don't sign any output, and anyone can just take your money. I mean, no one uses it, but yeah.
Turn a 2 into a 1 of 1.
Right. So there's ways to shoot yourself in the foot with Bitcoin already. So I don't worry too much about that. But yeah, that's what I think is the easiest way to fix it. Other questions? Yeah.
Is there a problem if a node drops out when there's still a number of off-chain transactions? What's the process of recovering from the node drop?
Yeah, so if a node drops out, it doesn't matter whether they are hostile or not hostile.
Same thing.
For you, it's the same thing. If the node drops out, effectively, if you have the relative maturity or relative check lock time verify, maybe your funds get locked up for about 2 weeks, 3 weeks, depending on what you set it to. Now that doesn't mean you can't spend your money. You probably have channels open with multiple people, maybe like 5 different people. So you probably won't even notice. Eventually, what'll happen is after a certain period of time, your client will automatically broadcast a certain transaction, or you don't even need to. Your client doesn't need to be online for. If you actually want to close it, you can just like push the transactions to 50 different people and give them some very small fee for broadcasting it.
Yeah.
So you could functionally, if you're using the system correctly, it shouldn't affect you at all. The other party can't steal your money.
Yeah, but worst case scenario is that that money in the channel is now inaccessible for the time period of the channel, which if it's too long could be. I mean, you could see how if you only have 1 or 2 channels open and one of them goes down, that was most of my money, and now I don't have access to it for a week or 2. So it can be a problem. So you do sort of trust the central nodes in that sense, but their main reputation is uptime. Like, this guy's got 5 nines uptime. He's always online. It always works. Cool. That's their only real metric of service.
Yeah, because they can't. You're not trusting them for your money. So
Yeah, just your time.
yeah.
Why would you even have a lock time of like weeks if you could just open a payment channel very quickly and inexpensively?
Right. So the question is, why set up the lock time to be weeks, like the relative maturity or whatever? So
Well, I guess you would increase.
the reason is because that number. So let's say like the relative maturity stuff, the relative check lock time verify gets in. Functionally, that's the minimum amount of time that you need to check the blockchain every so often that it is being, that the other party is not acting maliciously. So it's sort of like, you're just checking your mail. It's your
Yeah.
settlement time. Yeah.
If you open a channel that's only 2 days long, and you go away for a long weekend and just don't bring your phone, you might lose money.
If the other party is a jerk.
Yeah, if the other party's a jerk and you're not there to check during the entire period of your channel before it expires, you could lose, if someone sent you money, that send could sort of get canceled by that party since you're not there to broadcast it.
But you can even mitigate that.
Yeah.
You don't even need to watch it theoretically
someone
if
else.
you give the penalty spends to someone else. And those people can be just completely untrusted because they can't broadcast it unless the other party's a jerk. So, and then you give those people some very small fee as part of some signed transaction. So like if your counterparty is a jerk, then, like 100 other people are fighting to give you all their money, and they get some very, very small fee.
I'd say the more trust there is, the more efficient it becomes, and the longer these timescales can become. but that's the trade-off. And so like a week, 2 weeks, like we're sort of making up numbers, but those seem like reasonable time frames to use these things with. So
that time frame is kind of a function of how expensive the fee is on the main Bitcoin.
yeah. The fewer transactions you make, the longer they should probably be. So if Bitcoin transaction fees are very high, you might have 2-month long channels because it's worth it to keep that. So, but yeah, we don't know. We're just making these numbers up. So. Other questions? Good. Oh, okay.
So if we assume a future where the malleability fix is done, and then there's spends or non-confirmed transactions, does it get very, very messy if there's double spends, etc., and sometimes relying on
The issue with
What was the question?
the question is, if you've got this, malleability fix, do double spends become a problem? In these Lightning channel networks, almost everything is multi-sig. So in order to have double spends, they both need to cooperate. So in general, that's not an issue for these kind of things. Because if Alice and Bob both conspire to double spend, well, cool, right? Generally, it's an adversarial model where Alice wants money to go one place and Bob wants to go the other, and the multi-sig prevents any kind of double spending.
And the presumption is, you have many channels open, and it's interesting because people are like, well, even one confirmed, 10 minutes is too long. If something like Lightning exists, I can require an insane amount of confirmations, and I'm still good. I can be like, well, I won't allow this channel to be open until I get like 100 confirmations. It doesn't matter because everything's inside this channel.
Okay, other questions, or we're good? Finish? Okay, cool. Thanks.
Thank you.
Thank you, guys. Awesome. Cool. So before we go over to the lightning talks, whoever signed up can line up over there. We're going to try to pull up your website, and there's still room for other people. So we have like 5 places left. So whenever you think of something you want to share with us, just walk up there to Tom and share your website. I want to thank 500 Startups for hosting us today. They have an awesome location here, and on top of that, a great accelerator program. So if you want to hear more about that, Megan is somewhere around here. She's walking around here in a green t-shirt, so ask her if you have any questions. And then a special thanks to Coinbase, who's been our sponsor forever, and they offer us the pizzas and a beer, so thank you for that. And then let's get started with the lightning talks. You get 1 minute. And Jat, you're first. Do we have, I think you can wait. Do you want your website up there?
Yeah, that'd be great.
Okay.
I just saw it, so.
Okay, cool. They're working on it.
There it is.
Oh, there it is. Cool. There you go.
Thank you.
All right. Hello, everyone. I'm Jad Mubaslat. I'm here with my business partner, Chad Davis. And we've been here actually only since February. We came to join the Boost VC Bitcoin Accelerator. We're working on bitquick.co. We're changing the way that peer-to-peer trading is done. You might have heard of localbitcoins.com, where the buyer and seller interact directly. Well, we're taking out all the confusion. We're giving consumer protections and guarantees. So if you're an investor, developer, or you just want to talk, shoot me an email, jad@bitquick.co, or talk to me or Chad. Thanks, guys.
Next up. Oh.
How's it going, guys? My name is June. I just wanted to introduce you guys to a new meetup that I just started for the BitShares ecosystem, and it's really the first one in the West Coast. So we're calling it the Genesis Block Meetup. But most of the core developers for BitShares is in the East Coast. So I decided to help out and start up a meetup. Its first meetup is on June 16th. We don't have a location yet, but hopefully for those that are interested, developers, entrepreneurs, or anyone who wants to be an early adopter of BitShares, you can see there's not too many meetups yet, so you'll be an early adopter. Just real quick on BitShares, it's it's a complementary blockchain to Bitcoin. It's got something called Bit Assets, BitUSD, BitGold, that track the US dollar, gold prices. It has a decentralized trading platform on the blockchain. And so anyways, please check it out June 16th and talk to me afterwards. Thanks.
Hi, y'all. I'm here with co-founder of Bitseed, Mike Doty. He's a mechanical engineer. He helped build this fine, dedicated Bitcoin full node hardware, bitseed.org. We have a community on the website assembly.com where people can join to help us develop apps for this personal server that you can basically run at home. Right now, it's a plug-in Bitcoin node, so you just plug this device into power and your router, and it'll spin up a Bitcoin full node and synchronize with the Bitcoin blockchain. But as a personal server, there's all other kinds of apps that you could develop for this device. So if you want to buy one of these devices, you can get it off of bitseed.org. If you want to help us develop some apps, assembly.com/bitseed. Thank you.
Ahoy, hoy. My name is Josh Cincinnati. I'm the newly minted, no pun. Just waiting for that to settle a little bit. Developer advocate at blockcipher.com. I just joined about a month ago. You'll see me wearing this shirt. I swear to God, I have more than one of them. It doesn't smell that bad, but I'm wearing this shirt at every meetup. To anyone who's interested at all in building anything on the blockchain, Bitcoin is obviously the one that we support the most, but we also support Litecoin and Dogecoin. I am now an expert on the API, and I'm happy to help anyone who's trying to build something cool on the blockchain. So come find me. I'm very friendly. I'm not a jerk like the abstracted counterparty of every single transaction we've seen in the prior presentation. Yeah, find me. That'd be great. Thanks.
Going once, going twice? No? Okay, cool, thanks. Just enjoy the drinks. This is it.